At the end of the topic, you will be able to define a matrix, determine the order of the matrix, differentiate the various types of matrices, compute the transpose of a matrix. Matrix. Here, you can see a classroom where students are seated in row-wise as well as column-wise. Can you guess how you can relate this to any mathematical concept? Well done, your guess is right. This setup is nothing but a matrix. Definition of matrix. Matrix is a rectangular array of entries displayed in rows and columns enclosed within square brackets or parentheses. Matrices are usually denoted by the capital letters of English language. Here are some examples of matrices. A is equal to 1, 0, -5, 7, 4, 2. B is equal to A, B, C, D, E, F. Components of a matrix. In a matrix, rows are counted from top to bottom and columns are counted from left to right. Consider the matrix A. Here, the horizontal arrangements are known as rows and the vertical arrangements are known as columns. Here is an example. Let us consider a matrix A. 2, 4, 8, 6. Row 1 contains 2 and 4. Row 2 contains 8 and 6. Likewise, the entries 2 and 8 are in column 1, 4 and 6 in column 2. Also, you can observe that there are 2 rows and 2 columns. This is a 2 by 2 matrix. Order of the matrix. The number of rows and the number of columns present in a matrix denotes the order of the matrix. Generally, if a matrix contains m number of rows and n number of columns, then we can say that the order of that matrix is m by n. Here are some examples. What is the order of the matrix? 3, 8, 5, 7, 9, 1. What is the order of the matrix X? Equal to A, 0, B, 0, C, D, E, 0, 0. Click on the solution button to view the solution. Let's now see in detail about the types of matrices. There are different types of matrices. They are row matrix, column matrix, zero matrix, square matrix, rectangular matrix, diagonal matrix, scalar matrix, identity matrix. Row matrix. You can see that the fruits are arranged horizontally in a single line to form the row matrix. A matrix having only one row is called a row matrix. Column matrix. Here, the fruits are arranged vertically in a single line to form the column matrix. A matrix having only one column is called a column matrix. Zero matrix. A matrix A is said to be a zero matrix if all the elements are zero. This is also known as null matrix. The first is a zero matrix of order 2 by 2 and the second one is of order 2 by 3. Thus, we have zero matrices of any order. Square matrix. A matrix in which the number of rows and the number of columns are equal is called as square matrix. Thus, the matrix having 2 rows and 2 columns is a square matrix of order 2. A matrix with 3 rows and 3 columns is a square matrix of order 3. The diagonal from the first element of the first row to the last element in the last row is called the principal diagonal of the square matrix. The elements along this diagonal are called principal diagonal elements. Rectangular matrix. A matrix for which the number of rows and the number of columns are not the same is known as a rectangular matrix. A matrix of order m by n, where m not equal to n. For example, consider a matrix A equal to 1, 5, 7, 8, 2, 6. The order of the matrix A is 2 by 3. Number of rows equal to 2. Number of columns equal to 3. We found that the number of rows is not equal to number of columns. Therefore, the matrix A is a rectangular matrix. Now let us discuss the diagonal matrix. In a diagonal matrix, all the entries except the entries along the main diagonal are 0. In the matrix given below, there are 3 different rows representing 3 different numbers along the principal diagonal, and the remaining elements are 0. Scalar matrix. A scalar matrix is a diagonal matrix in which all the entries along the main diagonal are equal. In the matrix given below, 3 identical stars representing the same number present along the principal diagonal, and the remaining elements are 0. Identity matrix. An identity matrix is a scalar matrix in which all the entries along the main diagonal are equal to 1. This is also known as unit matrix. I3 denotes an identity matrix of order 3. Let's now learn the transpose of a matrix. The transpose of a matrix A is a matrix obtained by interchanging its rows and columns. The transpose of the matrix A is denoted by AT. For example, if A is a matrix of order m by n, then AT is a matrix of order n by m. In the given matrix, if we write the first row elements as the first column elements, the second row elements as the second column elements, and the third row elements as the third column elements, we get the transpose of the matrix. In this topic you have learnt, a matrix is a rectangular array of numbers enclosed within brackets. A matrix with m rows and n columns is of order m by n. A matrix having only one row is called row matrix. A matrix having only one column is called column matrix. A zero matrix is a matrix which has all its elements equal to 0. If the number of rows equal to number of columns, the matrix is a square matrix. A matrix for which the number of rows and the number of columns are not the same is known as a rectangular matrix. Diagonal matrix is a square matrix which has non-zero elements along the main diagonal with all the other elements equal to 0. Scalar matrix is a diagonal matrix whose main diagonal elements are equal. A unit matrix is a scalar matrix with the main diagonal entries as 1. The transpose of a matrix is got by interchanging its rows into columns. At the end of the topic you will be able to add and subtract matrices, recognize the properties of addition, multiply a matrix with a non-zero scalar, check if the matrices are conformable for multiplication, multiply matrices, Explain the properties of multiplication. Arithmetic operations. You will be very familiar with basic arithmetic operations like addition, subtraction, multiplication, and division. The same way, matrices can also be added, subtracted, and multiplied. Before going in detail about the operations on matrices, we will discuss the equality of two matrices. Consider a 2 by 2 matrix. A equal to 2, 4, 6, 8 and B equal to 2, 4, 6, 8. Compare matrix A and matrix B. You can see the corresponding elements of the two matrices are equal. Thus, matrix A equals matrix B. Hence, you can define the equality of two matrices as two matrices A and B are said to be equal if both the matrices A and B are of the same order or size and the corresponding entries in both the matrices A and B are equal. Let us see examples based on the equality of matrices. If the matrix 1, 2, 3, 4 equal to A, B, C, D, then find the value A, B, C, and D. Also, if two matrices 2, 1, 3, 4 and A minus B, 1, 3, A plus B are equal, then find the values of A and B. Click on the solution button to view the solution. Now we discuss the operations on matrices. Addition of matrices, subtraction of matrices, multiplication of matrices. Addition of matrices. Two matrices are said to be conformable for addition only if they are of the same order. Matrix A of order m by n can be added to matrix B of order m by n. The resulting matrix A plus B is also of the same order.
Here are the properties of addition of matrices. Matrix addition is commutative. That is, if A and B are two matrices of the same order, then A plus B is equal to B plus A. Matrix addition is associative. That is, if A, B and C are three matrices of same order, then A plus B plus C is equal to A plus B plus C. Identity of property of matrix addition. That is, if A be a matrix of any order, then A plus 0 is equal to A is equal to 0 plus A, where 0 is the null matrix of the same order. Inverse property of matrix addition. That is, if A be a matrix of any order, then A plus minus A is equal to 0 is equal to minus A plus A, where 0 is the null matrix of the same order. Here is an example to prove the properties of addition of matrices. If A is equal to 4, minus 2, 5, minus 9, B is equal to 8, 2, minus 1, minus 3, and C is equal to 3, 2, 5, 1, then prove that A plus B is equal to B plus A plus B plus C is equal to A plus B plus C. A plus 0 matrix is equal to 0 matrix plus A is equal to A plus minus A is equal to minus A plus A 0 matrix. Click on the respective solution buttons to view the solution.
Let us now look at the subtraction of matrices. If A and B are the matrices of same order, then the matrix A minus B is defined as the sum of matrix A and matrix minus B. A minus B equal to A plus minus B. To get A minus B, subtract the elements of B from the corresponding elements of A. A minus B is also called as the difference of A and B. Scalar product of a matrix. If a matrix is multiplied by a real number, then the product is called a scalar multiplication of a matrix. Here are the properties of scalar multiplication. If A and B are two matrices of the same order, then K into A plus B equal to Ka plus Kb, and A plus B into K equal to Ak plus Bk. K into A minus B is equal to Ka minus Kb, and A minus B into K is equal to Ak minus Bk. For any matrix A and any scalar quantities x and y, x plus y into A is equal to A into x plus y equal to Ax plus Ay. Here is the criterion for multiplication of matrices. Two matrices are said to be conformable for the product AB if the number of columns in A is equal to the number of rows in B. Here are the properties of product of matrices. Matrix multiplication is not commutative. That is, AB is not equal to BA. Matrix multiplication is associative. That is, A into BC is equal to AB into C. Matrix multiplication is distributive over addition. That is, A into B plus C equal to AB plus AC. A plus B into C is equal to AC plus BC. Identity property of matrix multiplication is AI equal to IA equal to A, where I is a unit matrix. Here is an example to prove the properties of product of matrices. If A equal to 1, 8, 4, 3, B equal to 1, 3, 7, 4, and C equal to -4, 6, 3, -5, then prove that AB is not equal to BA. AB into C is equal to A into BC. A into B plus C is equal to AB plus AC. AI equal to IA equal to A. Click on the respective solution button to view the solution. In this topic you have learnt only the matrices of same order can be added or subtracted. When a matrix is multiplied by a scalar k, every element of the matrix gets multiplied by k. Addition of matrices is commutative and associative. If A plus B equal to 0, B is the additive inverse of A. A null matrix is the additive identity. Minus A is the additive inverse of A. If M by N matrix is multiplied with N by P matrix, the product matrix is a M by P matrix. Product of matrices is